servo motor basically used for the precision rotation. Okay, so it has some inbuilt components for the precision, and here in the inbuilt in the servo motor, so there will be an inbuilt controller. Okay, so that will taking care about the angle rotation. Okay, so here basically we are using a sensor feedback register or sensor position register, so that will turn the shaft with the precision. Okay, so that's why we will find out the precision in the servo motor. So basically it is called as an angle control motor. Okay, so it will turn based on the angle we are provided in the program. Okay, so it has three pins. The one is ground and another one is VCC, and last the yellow color pin is the control pin. So we have to use with any one of the digital pin here. Okay, so just connect ground to ground. Okay, just rotate. So first of all we have to connect ground to ground, and VCC to VCC, that is nothing but 5 volt. And next control pin, so I will connect this control pin to third pin on Arduino. So internally the servo motor library, so we will use servo motor library for rotation. Okay, so internally the servo motor library will use timer, so we will discuss the timer concept in the next upcoming classes. Okay, so this is the simple connection for a servo motor. Okay, so in the online simulation also we have the servo motor here. Okay, take servo motor and Arduino board and breadboard. So here I don't use breadboard. Okay, I will directly connect the motor connection. So here we have the different color. Okay, so the brown is the ground. Okay, so this was the ground. So just wait a minute. Okay, ground, and middle one is the power VCC pin. I'll change the color. You have to connect it to 5 volt, okay, not 3.3 volt. And last one is the signal pin or output pin. Okay, I will connect it to third pin. Okay, so now for rotation, so we'll use inbuilt function. Okay, let's start with the coding part. So first of all I will write the code in Arduino Ide. Okay, so this is the previous code. Okay, just I will take a new file, a new sketch. So just include the servo library first. Okay, so go to sketch and go to include library, then search here for servo. Okay, here we have the servo, just click on that, so it will add it automatically. Then create an object similar to the LCD display. Okay, servo, you can give the name, any name. Okay, so here I will give my servo. Okay, so and so this is the creation of object. So then I will attach to the particular pin. Okay, here you can see here we are connected the signal pin to third. Okay, so that's why we have to select that pin. Okay, so instead of pin mode, just go for my servo. So here my servo, and dot attach. So that will make the particular pin as an output mode. Okay. So here I will use third pin. Okay. This is the pin initialization of for servo. Then we can go for the position control directly. Okay. So here it is called 180-degree angular rotation. So here we are using 180-degree angular rotation servo motor. Okay. So it will rotate only 0 to 180 degree. Okay. So for that purpose, you can directly provide the number, okay, or degree number. Okay, so here just go for my, okay, my servo dot right. Okay, in the parenthesis, so you can give the number or angular value. Okay, so I will start with 0 degree. Okay, so then I will give the delay for 1 second. Okay, then I will rotate it to my servo. Okay, so I will make it as 0 in the wire setup. So firstly I will fix this position into 0 position, okay, or 0 degree. So after some delay, so after 2 second delay, I will change the direction. Okay, my servo dot right. I'll rotate into 90 degree. Okay. So just compile the code. Let's see. So whether the code is correct or not. Done compiling. Okay, then upload the code. Now before uploading, check the COM port and the Arduino board. Okay, here we are using Arduino board and COM port is COM4 and Arduino. Then upload the sketch. So done uploading. So now I will connect the servo motor to Arduino. And wait a second. So these are the 3 pins. Okay, brown color is ground. We connect it to ground. And middle pin is the VCC. Middle pin is the VCC. And the signal pin is connected to the third pin. Now you can see the position now. So once again I will upload the code. So this is the 0th position and this is the 90-degree position. Okay. So again I will reset the servo motor or microcontroller 0 degree and 90 degree. Okay. So like that you can control the angular position of servo motor. In the simulation part you can also do that. So just write the code again. Okay. For including library, so here the library and search for servo. Here we have the servo. Okay. A similar case, servo. All right, my servo. Okay. And attach the pin. dot attach pin number 3rd. Okay, then go for rotation. My servo dot right, so 0 degree. Okay, I'll make continuous now. Okay, delay 2 seconds, it will wait for 2 seconds, and again I will come rotate that servo into 90 degree. 90 degree. Okay, delay of 2000. Okay, semicolon. So let's simulate the code. So you can see here. So this is the 0 degree position and 90 degree. Okay. So now we'll do the 180 degree. Okay. So instead of 90 degree, I'll make it as a 180. You can see the angular position. Okay. So if I give one more than that, so let's see. So it can 280 degree. So maybe in the simulation part we'll see. Okay, it's rotating only 180 degree. You can see that. Even though I given larger than 180 degree. Okay. So it won't support more than 180 degree. Between 0 degree to 180 degree. So we can control the servo motor. Okay. Either before going to the another. Okay, this is the code. Upload the sketch. Zero position. It is in the continuous form. So now we are doing 0, 45 degree and 90 degree and 125, 145, 160 and 180 degree. Again it's start with the 0 degree. So upload the code again. So 0 degree, 45 degree, 90 degree, okay, 125, 145, 160, 180. Okay. So now I will use for loop for rotating 0 to 180 degrees step by step. Okay. So for smooth rotation. So instead of writing this much of code, just I will reduce. Just go for loop. Okay, for loop. So I will take int position. Okay, int position equals to 0 and I less than or equals to. So we have 180 degree. So every time I will increment by 1. Okay. Then open curly brace. Close the curly brace. Okay. So every time I will go for the position. Okay. Sorry, here we have to take position. Okay. So right position. So here just give the minimal delay here. So just I will take 20. Okay. So let's see how it will respond. Done uploading. So you can see here. So some of the, as compared to the previous rotation, it is smooth, right? So So just you can also decrease the delay, or you can increase the delay. Okay, so it is faster, right? So then I'll take 30. Okay. So if you want a slower rotation, you can just increment the delay here. Okay. So now, so you can also do in the anti-clockwise also. So it is in the clockwise. Okay, you can also do in the anti-clockwise. So here just it will start with the 0th position and it will end with the 180 degree. So again it will start with the 0 because of we are in the loop. Okay. So now I will view again. So if it is reaches to the maximum count, so again I will start with the maximum count and I will go for the decrement order. Okay. So for that again I will use the delay here for okay. So just go for the for loop. For loop int reverse, okay, is equal to 180 degree, okay, and reverse greater than or equals to 0 and reverse minus minus, okay. Again write the my servo dot write, okay, and reverse and give the delay as 30. Okay, upload the code. Okay, it will start with the 0th position and it will end with the 180 degree. Okay, so again it will start from the 180 degree and end with the 0 degree. So this way you can control the servo motor. Okay, for okay, so just connect servo motor to you are controlling servo motor from 3rd pin and controlling IR sensor from A0 pin. So now you again. Now again explain. Okay, see here the block diagram. Okay, just we are coupled with the IR sensor to A0 pin and servo motor to 3rd pin. Okay, so here just when the hand is detected, so it will directly turn on. Okay, it will directly rotate from 0 degree to 90 degree. So then the sanitizer will dispense. Okay, so again after some time, or else so based on the information from the IR sensor, you can directly turn it on or turn it off, okay, while writing the program. So just once hand is detected, so you are turning or you are rotating from 0 to 90 degree. If it is not detected, so then you are turning from 90 degree to 0 degree. Okay, so this is the code for this operation. Okay, so here we are attached 3rd pin for servo and A0 pin for the IR. The initial position it is in the position of 0 degree in the loop section. So you are continuously reading the IR sensor value. Okay, if it is low or if it is 0, so that means so here the object is detected. Okay, or hand is detected. Okay, then you are rotating our servo motor from 0 degree to 90 degree. That means you are dispensing. Okay, dispensed, okay, or dispense sanitizer. So here 0 degree means, so from 90 degree to 0 degree means dispense. Okay, So this is the operation. So now I will upload this code. Okay. So before that I need to connect IR sensor. Uploading. So done uploading. So you can see here. So it is in the 0th position. So by default. So if the hand is detected, so it is automatically turned to the 90 degree. Okay, you can see here. Okay. So if it is a hand is detected, so it is turned to 90 degree. Okay. It will change its direction. Okay. So this is the 50% part. Okay. So this is the software part. So if you want to dispense a sanitizer, we need to build in a model. So that is the hardware. Okay. So then we'll come to the product called embedded product. So that is called automatic hand sanitizer. Okay. So this is means a combination of hardware and the software. Okay. Okay. So either you can also give the some delay. Okay. So automatically. So this is the one way of doing the code possibility. So now I will show you another. So just instead of taking else, so directly I'll go for here. If the object is detected, so then I'll rotate my servo motor from 0 degree to 90 degree. So and just I'll give the delay. Okay. So just I'll give the delay called around 2 seconds or 1 second like that. Okay. So after that I'll automatically rotate servo motor to 0 position. Okay. So my servo dot right. So 0 position. Okay. So this is also one way writing the code and upload the code. Okay, now you can see the difference. So after 2 seconds it will back to the normal position. Okay. So we are in the continuous state, right? So just after the 0 position you can also give the delay at 2 seconds. So then uploading. Okay. So after 2 seconds so it will automatically return back to the its original position. Okay. But this method is not effective method. Okay. So you can see here, if the hand is continuously detecting, so it will after every 2 seconds, so it will again dispense the sanitizer. Okay. So this method is not effective. Okay. So for that, so if you are using servo motor, so this is the not an effective method. So go for the previous method. Okay. So this is effective. So in case of some water pump or other motors, so this one is the effective method. Okay, effective method. Okay, this one is the effective method. So based on the hardware devices, so you can write the code. So this is a simple automatic hand sanitizer code. Okay. So just you are detecting. Okay, you are reading the information from the IR sensor. So if it is hand detected, so then it will rotate the servo motor for dispensing sanitizer, and if it is not detected, so then it will return back to the normal position. Okay. So any doubts in this code? Assignment is write a program to turn on LED when one is received from serial monitor and turn off the LED when 0 is received. Okay, this is my question. So I will discard this program. So for initialization of UART, we need this statement. So serial dot begin.
Excuse me.
Sir, screen is not shared, sir.
Okay, fine. Okay. The first of all, so we have to initialize the UART. So for initializing, so we require this line. So serial dot begin 9600 is the baud rate. Okay, communication baud rate. Okay. So then initially I will print the message. Okay. So serial dot print ln. Okay. Send 1. Okay, send 1 for turn on LED. Okay. And the meantime, again I will take another line. Okay, serial dot print ln send 0 or turn off LED. Okay, or to turn off the LED. Okay. So this is the initial message. Okay. After that, so for reading, so the check, first of all we have to check the whether data is present on the serial monitor or not. Okay. So that purpose, so serial dot available. This is the first condition. So it is greater than 0. So then enter into the loop. In that loop, just take character or string. Okay. So you can take both, but don't take integer. So I'll take character just for I'm checking the 0 or 1, right? So that purpose I'll take character. So character, so received data. Okay. Or you can also take that your data. Okay. So I'll take you serial dot read. So it will read the data from the serial monitor. Okay. And go for check the condition if received data is equal to 1. So if you are taking like this, so this is invalid. Okay. So but you don't get any error, but you so sometimes the based on the version, so we'll get an error. Okay. So basically, so we have to take the 1 in the character type. Okay. So this is the integer type. Because of you are receiving the data in the character means, so we have to initialize, you have to represent with the character. So this is character. Okay. And remember, so in the C program, don't use any semicolons for the if for loop statements. Okay. So that is invalid syntax. So now again, if the received data is equal to 1, so then I will turn on the LED. So we are going to turn on the LED. So just by writing the digital write. So here I will take LED comma 1. Okay. So for that, so we have to declare LED first. Okay. So how we are going to declare? So you can use as define LED 13. Okay. So you can also do like this, or in the other way. So you can also use const int. Okay. Const int LED is equal to 13. So in either one way you can define the LED. Okay. So after that, so make that pin as an output, comma output. Okay. So don't take else. Okay. Here if you are taken like this, So what will happen? If the data is 1, so it will turn on the LED. If by it means you are sending anything else except 1, so then it will turn off the LED. So this is not my requirement. So when 0 is received, so then only we have to turn off the LED. So that's why take else if for if okay. So both the conditions are valid. So just I will take receive data is equal to 0. So then I'll turn off the LED. Digital write LED comma 0. So if anything more than anything, okay, just I will give the output for this program, okay. So after that I will update the code. Okay. So this is simple code, just you are reading the data and you are checking the condition, that's all. So upload this code. The code is uploaded, okay. Just I will open the serial monitor. So what is the initial message here? So send 1 to turn on the LED, send 0 to turn off the LED. So in the Arduino board, so just see, so the inbuilt LED is off, okay. So now I will send 1, so it is turned on. If I am sending 0, so then it is turned off, okay. 1 on, 0 off. Otherwise we can also connect external LED, okay. So send 1, it is turned on, okay. So send 0, it is turned off. So you can also print the message here. So using serial print, serial dot println LED is on. Okay. So in the else part, so we can also print serial dot println LED off, or you can say that. Upload the code. So done uploading, okay. So send 1 to turn on the LED, send 0 to turn off the LED. So now I am sending 1, so LED is on, 0 LED off, 1 on, again 1 on, okay, 0 off, okay. So giving me the quick response, okay. You can see here the quick response. Okay, fine. So see here what often if I'm sending wrong information, okay. So well, if I'm sending 1, so it's doing its operation, okay, 0. So if I'm sending something, okay, so like 4, so it's do not do anything, but it's ignoring, but you have to display some information, right? So if I'm sending other than 0 and 1, so just to display the one message, okay. So should give the correct response, or send only the number 0 and 1. So like that you can print the message while sending, okay, or user sending other than 0 or 1 value, okay. So like that if I'm sending 5, so just it will print. So I want to print, so just enter the character or just send the character 0 or 1, okay. Or you can simply display invalid character, so like this, okay. So we are going to do that. So then go for the else if condition now. So if it is 1, so it will turn on the LED. Else if the data is 0, then it will turn off the LED, and then else. So just I'm not doing anything, just I'm printing, okay. So invalid character, invalid character, serial.print ln again, or just I will give the delay for interaction. So 1 second, okay, 1 second, and I'll print send send the number, okay, 0, okay, so it's not 0, 0 and 1 only, okay. Okay, after that we can upload the code. So let's see what it will give. So send 1 to turn on the LED and send 0 to turn off LED. Okay, so now I will send 1. So LED is on, LED on, but you are getting so invalid character. Send the number 0 and 1 only. Okay, invalid character. So you can see here what happened here. So if the data is okay. So after in the loop, so just okay here. So just reload with the empty character. Okay, so just receive data with the empty character. Okay, so then again we will get an invalid. So done uploading. Let's check it once again. So if it is 1, so we are getting an LED on and invalid character. So 0, so LED off, again invalid character. Okay, so to avoid this, so I'll update the code. So just I will take a global variable. Okay, so like this. So take a global variable, receive data, and then I'll end the loop here. And we have to remove one more. Okay, for the 4. So done uploading. Okay, let's check it the code. So by default it's showing that so invalid character, send the number between 0 and 1 only. So because we are writing the code in outside the loop, right? That's why. So now I will take into the if loop. Then open the serial monitor. So LED on. So again it's showing that invalid characters and the number 0 and 1 only. Okay, 0 of 1 and 0. Okay, I think so. Again we have to take the while loop again. So in the serial dot available greater than 0, so then again if it is entered, so then we have to go for the while loop. So I will update this code. Okay, so otherwise if you do not want to show anything, so just stop it to the 2 loops here. So if and another if, or you can take else if. So this is simple code for taking the user inputs from the serial monitor. Okay. So now like that, so you can also build. So you can also receive the character. So like not only one. So you can also make use of characters like M, N, okay, so or L or O, so like that. Okay. So you can also turn it on by using string. Okay. So if you want to take string, so now I will take LED on. So then, so if I am sending LED on, so then only LED should turn on. Okay. If I am sending LED off, so then only it turn it off. Okay. So like you can also do. So just take instead of character, just take a string data. Okay, here also string. Okay, you can instead of read, just use a string, then go for string. Okay, here. So LED on. Here LED off. LED off. Okay. So just you have to make these changes for checking the string. Okay. So just I will upload. Done uploading. Now I will send one. So invalid character. Okay. So now I will send 0. Invalid character. Okay. So now I will send LED on. So again it is showing that invalid character. Let's see. LED off. Okay. LED on. Your string receive data. Just a minute. I will print the string again. Serial dot print ln. Okay, receive data. Let's upload the code. Okay. Just open this one. Okay, 1 invalid, 0 invalid, LED on, invalid character, okay, LED off, LED off, okay fine. Wait a minute.